Hi guys, welcome to LTS webinars. Thank you for joining. Before we start, I would like to introduce you to our Q&A modality. So during the presentation, if you have a question, please find an icon called Q&A and type your question there. Just right, you can see it at your screens. Well, guys, we'll answer your question, the most interesting of your questions after the presentation. Well, if you have some, organizational questions or comments, please type it in the chat. So I hope you will enjoy the presentation, and now I will pass the word to our speakers, Ionut and Xavier. So please, guys, welcome.
Thank you so much.
Thank you, Julia.
You. 1 second to share my screen actually. Okay, so I suppose we can kick off, right, Xavier?
Yep, we're ready. Okay, welcome everyone. Welcome to Building Evolutionary Architectures. Let me get to the next slide. If it comes. Okay, so first a small word about us. I am Xavier Rene. I'm working for Murex as a software engineering lead and a large-scale agile coach.
Okay, and I'm Balosin. I'm working as a software architect in Luxoft. And together with Xavier, we'll share based on our expertise how we mix architecture in our agile environments.
So first, one of the inspirations is this book, Building Evolutionary Architectures. Actually, this book was released just after we finished writing this presentation. However, we adapted the terms, the terminology, the vocabulary to this book because we think that Neil Ford will certainly have more readers, more audience than us. So what we will discuss during this presentation. First, we will visit some common misconceptions on both sides, agility and architecture. We think that a lot of people might find these two, this activity and these principles sometimes contradictory. So we will visit some of these misconceptions. Afterwards, we will prove you that when we step back a little, we see that architecture and agility actually share a common goal, which is to support future evolutions of the system. Then, once this said, we will see how to work actually together, how to actually do an efficient architecture in an agile environment. So I guess we can start by visit some common misconceptions of agility and architecture.
Okay, so great. Let's start with the first one. And I would like to ask you, Xavier, as being an agile expert, because when I read this Agile Manifesto, one of those principles says that it's favor responding to change over following a plan. From my architecture perspective, I don't feel quite comfortable without having a plan at all. Can you please explain what it means exactly?
Yeah, so of course, responding to change, this is one of the motto of the Agile Manifesto, but it doesn't mean that we don't have a plan, right? It means, at the contrary, that we have a plan, but we have also alternatives. We keep all options open. Basically, it's like you have an initial plan at the beginning, but you keep all options open to be able to avoid a traffic jam, to avoid a block road, or to catch a shortcut that appears in front of you. So clearly, responding to change doesn't mean no plan. On my side, I have a problem with the definition of architecture unit. I heard that architecture is about designing all the things that are very hard to change afterwards or are even impossible to change. I have two problems with that. I think that nowadays I don't know what is not subject to change. Things are changing so fast that I prefer to be ready to change that, say that this and this won't change. The second problem I have is that I don't trust anyone to be right the first time, right? So what's your take on this, Ionut?
Okay, so let me explain a bit. First, regarding to your second point of view, of course, nobody, or in very few cases, we might be right from the very beginning. From an architecture perspective, we might repeat the same tactics, we might do the same choices if the context is exactly the same. However, nowadays the volatility has increased a lot and it's not being right from the first time. Remember, a few decades ago or many years ago, the architect was the person that drawn the boxes and lines, everything big up front. Nowadays, it's not a big upfront. It's not about carving in stone anything, but to take those decisions which are mandatory at this stage, but as well to be flexible in time. So it doesn't make, for example, doesn't means that if I take something now, I shouldn't roll back later on. The question is how many decisions to take at this moment to be able to build upon them later on. But let me give you more on these architectural definitions, more insights. So going with this, we will zoom inside the next chapter and we will talk about first definitions from both sides. And actually, if you might search or Google about what the architecture means, you might find that a very simple definition comes from Ralph Johnson. He says that it's important stuff, whatever that's it. And it's very it's a very lucky definition if you don't know the basis. Also, for me it was difficult to understand it many years ago when I read it. And let's see what that important stuff means. Currently, we are living in a world of ELTs. We have ELTs like scalability, flexibility, maintainability, extensibility, performance, security, all of these. So we have this zoo of ELTs, and we software architects should build our product based on these ELTs. But of course, we can't take all of them because some of these ELTs contradict each other. For example, if you have like performance and security in your application and you want to wrap both of them, be careful because one may impact the other. For example, increasing security, which has tactics like encryption, may impact performance. On the other side, another balance should be between performance and modifiability. Modifiability, it's good because it's a way towards flexibility, towards extensibility. It makes easier the development of the product in time, but in some way it might impact performance. So we should take conscious decisions towards this kind of quality attributes. So roughly speaking, we live in a world of trade-offs, and these trade-offs, how we can deal with them, of course we can prioritize these ELTs, create a list of architecture significant requirement, and based on that actually build the product. But let me be more explicit. So in most of the cases, we need to listen to the stakeholders because the stakeholders can provide us the prioritization in regards to the first category of quality attributes. For example, listening to the stakeholders, we might prioritize across availability, scalability, security, performance, what makes sense for that product to satisfy the business needs. And there might be another category of attributes, we call them vital quality attributes, which complement the first category and ensures the first category evolution evolution in time. Because, for example, in this category, you may find attributes like testability, flexibility, maintainability. These might not come all the times from the stakeholders. However, us as architects must be sure our product ships those, because at the end, we also have evolvability, which is another share key ingredient which protects both of these categories in time. And that's why initially I was starting with this definition. The architecture is the important stuff, because we need to listen to the stakeholders. We need to combine the stakeholder elicitation process across the quality attributes with the second category, plus we have the evolvability, which ensures both of these categories to be achievable in time. So this is my understanding of the architecture in regards with how we should shape the product from an architecture perspective, actually.
Okay, so I can definitely buy this definition, because for me, if we explain what is agility, agility is the ability to move quickly and easily. Okay, it's simply that. And if you look at the manifesto addresses the capacity to make these changes around the organization, collaboration, planning, but of course, and most important of all, the software. And if you look at the design of the extreme programming, then you will find these same quality attributes of maintainability, testability, simplicity, which are at the heart of extreme programming. So when you look at this definition and you step back and you compare it to your definition, I would say that again here, software evolvability is at the heart of our concern. So clearly, we can say that agility and architecture design share the same common goal of ensuring the evolvability of our system. So I suggest that we go past these main conceptions and we see how we can work together, agility and architecture. So in the coming section, Ionut will explain us what is an agile architecture, how architecture can bring these benefits to our product. Then I will describe how agility can help the daily work of an architect. And then we will see that life is not pink and that there are still some challenges to address.
Okay, sure. Thanks, Xavier. So we just saw that we both share the common goal. Now let's zoom inside the architectural side, and let's see some anti-patterns or not agile architectures. So the first anti-pattern, it's in regards to the big ball of mud, and this is the screenshot took out of JDK 7. If you are Java developers attending this presentation, it seems very familiar to you. What happened in 2009 before the jigsaw, before the modularization project to happen, as you can see, a lot of modules depend on others in some sort of spaghetti dependency network. This is very, very dangerous because it becomes everything very tightly coupled with the other components. Another thing is that, for example, if you use, for example, services or microservices pattern, it doesn't really matter. You may end up with a lot of dependencies across those microservices, which makes your life even more difficult. Imagine, for example, if you want to replace or upgrade one service, how many other services will be impacted by that upgrade or by that replacement. So these are some common anti-patterns that might easily happen in your project. Also, for example, when you design your system and you end up in isolation, each service to be isolated enough or to encapsulate its own proper logic, be careful with the data that flows between those services. Because, for example, if you change the data and that change affects many services, in this picture, you can see that the red services affected by a change in data. Probably it's not quite a good design because those services are coupled by data that flows across them. Also, you can create coupling across modules, packages, and so on by other shared components. For example, in case of microservices, this pattern might not be very recommended because it's better to share nothing in microservices architecture. Also, in domain-driven design, that bounded context doesn't allow you to share something, because sharing something, once you upgrade that shared, if it is not backwards compatible or changes somehow the API, you impact all the modules that relies on it, and you need to release everything again. So basically the quota that it's released, it's keep on growing. Also, you can create, for example, coupling with transactions, especially if you have distributed transactions. For example, as you can see here, you have service 1 and service 2, and the client sends a request, and if that request enlists both services within the same transaction, maybe it's not a good design, because you need to keep coupled service 1 and service 2. And that's why, for example, in our environment, we try to get rid as much as we can on these distributed transactions, because they create coupling across services, across components. And having all of this in mind, let's see, for example, for other people, other stakeholders involved in the project, what are the consequences of having a not agile design? Because for us, technical guys, might be less easier or less understandable. But for other guys, what would be the symptoms? First one is when you have features to incorporate in your project, those features could be either very hard to be integrated, because, for example, you want to add something and you change something else, or you cause side effects. Either they couldn't be integrated because the product is not flexible, doesn't allow that, and all this kind around. Either, for example, in terms of releases, if one small modification takes few months to be released until the end user benefit of it, it's a sign that the product is not agile enough. For example, getting back to the Java world, until recently, each major Java release happened once in 3-4 times, for example, which is still not good, because the user needs to wait a lot of time until it benefits. This is also with the architectures that are not agile, and the components are very, very bundled or coupled together. You pay a lot of price releasing those, and also the product itself becomes heavy and difficult to carry on in time, because from the customer perspective, he must wait more until he uses or until he benefits out of those features. And more than that, once those features come in, the customer has a lot of features once, a single shot actually. And if something crashes, imagine what might happen at that stage. Probably you need to roll back or you need to patch. So it will take another month or another weeks at least to test and to go through the entire UAT process. And Having all of this said, let's see what would be some design principles or ingredients for achieving these agile architectures. The first of all, so-called design principles. Probably you may already know all of them. These are basics. These principles came many years ago, but I think nowadays we are struggling more and more with them. There is nothing, something new invented recently. If you read, for example, papers from 90s, from 80s, you'll find all of these principles, most of them. For example, don't sacrifice loose coupling for performance. First of all, when you design your application, don't think about how you should tweak or how you should implement in a very, very complicated way just to hit the quality attributes like performance or horizontal scalability or ultra highly availability. Be careful with the design principle. First, satisfy the design principle, for example, loose coupling. Also prefer composition over inheritance. Why? Because composition also adds loose coupling between those parties. Messages atomic and services stateless, it's a very, very good recipe if you want to scale horizontally especially. And if your interfaces have, for example, boundaries which are coarse-grained, it's even better because having that, you can minimize, for example, the number of round trip times across the network, or if you want to change something under the hood, the API it's more stable, and also inside the modules, high cohesion is very, very important to be satisfied. Also, the solid principles, don't repeat yourself or you aren't gonna need it. This kind of principles help you a lot. So first of all, this is, at least from my perspective, these are the common ground of building an agile architecture. And then if we have to make a review across architectural styles, what we had in the beginning when the people lived in the waterfall era, we have those big monoliths. Inside that monolith, you might have like a big ball of mud in terms of dependencies across components, or you have a structure monolith, which, by the way, it's not a necessary bad architecture. But the problem with this monolith, in essence, as we already saw, is that you pay more cost in releasing it because you need to wait more. It is not scalable. There is a single point of failure and all the things around. So what happened, especially with the J2EE, it came up with these layered architectures. What's the idea around it? So what would be to split, for example, the logic, the business logic, the presentation logic, the integration logic in one of its own layer. In this way, we easily segregate this logic. However, imagine if you want to implement a feature, it's not very convenient to cross all of these layers. In some cases, due to performance, for example, you might choose to bypass some layers if the logic inside that layer has nothing to do with the initial request. Also, if you want to scale, the question would be, how should I scale a layered architecture? Should I scale one layer in itself, or should I scale all the layers and so on? So still not very efficient. And afterwards, they came up with the idea, what would be, for example, to isolate the services, to encapsulate the logic, to deploy them independently, and to create some sort of intermediate layer, as we can see here in the picture to do the routing, the transformation, the processing, the orchestration, the choreography across all of these services, and the client to be very loose coupled with those services. And this type of so-called architecture style, which is service-oriented architecture, was very on fashion like 8-10 years ago, but it reached its limitation. Why that? Because the ESB in time became very heavy. The ESB in time was closer to a monolith because it contained a lot of logic. So still not good. And we decided to split the logic and to create those services very coupled, and we ended up with microservices architecture. But basically microservices architecture, I would say it's just so addressed in new clothes actually, because you as a client need to know of each service. This is one way. Another way, you can put a gateway in front and so on. So you can see that the same idea of services loose coupled, developed in isolation with the logic very well encapsulated. So you can scale very easily, but on the other side you can add a lot of complexity. Microservices is a good pattern also if you want to scale all the teams themselves, because remember the Conway's law. For example, your organization structure might reflect in your architecture. For example, if you have isolated teams, each team is responsible with few services, you can scale the development quite fast. On the other side, there are some pitfalls, because if you don't pay careful, you might end up with that dependency across services, which might go towards hell and so on. And recently, another architecture style coined serverless appeared, which is basically based on two ideas: a backend as a service. So I have a service in the backend. Why I shouldn't use it? For example, the authentication service or database service. And why not, if I have my logic wrapped inside the component, why I shouldn't just deploy that inside the container, which is an ephemeral container, event-driven, out of my infrastructure. So in this case, I shouldn't pay too much for the deployment, for the operability, because it's not my infrastructure. On the other side, this one, it's not the silver bulletproof, because we lock in too much in the vendor solution. Plus, for example, if you want to customize the solution in terms of performance, very refined settings, most of the providers don't allow you to that, because you basically live in their container. Okay, so if you look across all of these architecture styles, I might ask you, what do they have in common? But I would ask Xavier actually, because he is on the line. What do you think, Xavier, have all of this in common? What's the trend?
I was thinking that you would say go to serverless because it's the new thing. So you say that there's something in common. I think that all the boxes in all these architectures are quite isolated, no? Or
Yeah, so that's the idea, to develop logic which has a good cohesion, to be deployed independently, to be easy to scale. And now regarding to the infrastructure, if I deploy it in my infrastructure or vendor's infrastructure, there is a second part of the topic, but basically this is the trend. And in regards to that, in regards to the architecture style, you should you should be very careful with the component boundaries, because changing the component boundaries influences the others that depend or relies on it. So in regards with that, you should know in advance what is the communication mechanism with externals in terms of protocols. What protocols are you using? HTTP, FTP, what's the communication type? If it is synchronous, if it is asynchronous, the transmission way. Also, the messages exchanged, as I was saying, you can create coupling also by messages. So you should be very careful with the type and the format across them. Also, the dependencies, what are the components I depend on and what is using my component. And also pay careful when you design your APIs, because if you don't design the APIs carefully enough, it's very difficult to upgrade the API since the product reaches maturity, because you have a lot of dependencies on it. Also, inside the component, you should pay careful about cohesion, on coupling, towards exterior on encapsulation, and all the principles you might already know. And for example, there are some tools that does the static analysis, introspection in your code and measure all of these things, so you should complement those with some sort of tactics. Nevertheless, there might be other perspective you should take into consideration even from the beginning. For example, if your solution is time awareness, what it means. For example, if I work in a real mode trading system, for example, the time is very important. I should be time awareness. And in regards to that, I need to be very careful also with the trading model I should use, for example, fork join pool or thread pool, executors. What are the strategies that I should choose, for example, round robin, shortest job first, and all the things around. And also, if there is a limit in terms of resources, in terms of CPU, in terms of memory, in terms of queues, for example, to not let unbounded queues. Also, from the object and data model, I should know what are the models that corresponds to the business entities. Do I need the models or no? What would be the entities, the data access levels? For example, do I need, for example, an ORM, or should I just do a direct connection to the DB? Or also, in terms of retention preservation, you need to know as architect what is important, what fits better. Do I need, for example, to rely on RDBMS model or non-SQL model? What are the pros and cons? What fits better in my environment? And also, in terms of binding time decisions, later we take them, for example, later meaning runtime, more flexibility we offer to the final client, and more agile we develop our product. Because if we bind those decisions later on, offering flexibility, extensibility of the product, the client itself can customize or can develop on top of it without being necessary for us to be involved. Of course, it's more effort for us, but in time the evolvability ingredient, it's more satisfied with this. And also we should pay careful even in the beginning when we choose the on programming languages, because these are irreversible decisions. Programming language, you can never change it once you start with something, unless you throw away the architecture and start with another one. And also with the frameworks, it's a very important mark. If you choose the framework and if you use a framework and you don't consciously choose the most appropriate one based on the technology metrics, elicitation process, a good rationale around that, it might become a bottleneck at the end. So be very, very careful with these two categories. Also, there is a very good advice from Uncle Bob Martin with clean architecture. He says that, as you can see here, there are a lot of circles. The business rules and the use cases around them shouldn't depend on the DB or on the UI, on the frameworks, but on contrary, framework, the DB, should have dependencies inwards towards the business rules, towards the entities, because in this way you can easily change, for example, the framework later on. And how you can do that in practice, for example, imagine on the left side you have the diagram, you have the business entities and the database. To create a loose coupling between these, don't depend from business rules directly to the database, but add very loose coupling layer, for example, an interface, and inside the business rules you use that interface which has a specific implementation for that database. In this case, you can easily plug in, plug out another one. And the same in terms of UI, for example. Don't depend from the business towards UI, but vice versa. And having all of these, the things that we went through, the principles, if we have these two, for example, state of the architecture diagrams, which one of those do you think it might be agile? And I like Xavier because he is on the line with me. Which one of these do you think it's more agile than the other?
Well, that's tricky. On top of my head, I would find one of the right too simple. That's suspect, and I can see that there is a data flow from the KLOG 1 to the DB. So you just said that it was not good, and I think the one on the left has more color, is more fancy. I should choose the one on the left.
Because it's more, it has a better look and feel, right?
Yes.
Okay, so basically, actually I don't have a proper answer to this question. Why I don't have a proper answer? Because I don't know the context. Just by looking on two diagrams or 3 or 4, I don't know which of those fulfills the business needs and all the requests around. Plus, on top of that, so without knowing the context, you can't judge effectively. Plus, the time, it's very important, because what was today or yesterday or 1 year ago a good architecture, today or in 2 months can't be. So also you should take into consideration the time. So that's why I was saying initially that it's very difficult to judge. You need to have the context plus the time in mind, and then you have to challenge the architecture if it fulfills all of the quality attributes plus the vital ones, and if you decide if it is evolvable or not. Okay, so now let's switch a bit the focus towards agility, and I'll let Xavier to explain how agility mixes with all of these technical things that I described in order to build the evolvability, the key ingredient that we discussed about.
Thanks, Ionut. So yes, we've seen how good architectures can enable agility. Now let's see how agility enables architecture design. So basically, what are the agile principles and practices that an architect can use on a daily basis to make a better work? First of all, Ionut, you said at the beginning that, yes, we don't value anymore big upfront architecture. We value just enough architecture. But what is just enough? It's difficult to know upfront what is just enough to start the development. In the Agile Manifesto, we have we always ask the customer, right? We have customer collaboration over contract negotiation. And what we do in Agile practices is that we regularly demo to customer and ask for feedback. When we ask for feedback, the customer can tell us, oh, no, that's not good. That's not what I wanted. Okay, we switch, we adapt. The customer can tell us, yes, that's good, very good, go on. And the customer can also tell us, hey, that's good enough. You can stop there because, yes, I wanted more at the beginning, but what you provided is good enough for me. Let's move to something else. Okay, so we can apply exactly the same principle for architecture design because we don't know upfront what is just enough. So let's start to design the architecture and let's demo this architecture to the team, to the development team at each sprint. And then at one moment, the team will be able to tell us, oh, okay, that's just good enough for me, so I can start the development right now. And then you will have your just enough architecture. Another principle of the Agile Manifesto is working software over comprehensive documentation. In Murex, the architects don't deliver documents, don't deliver paper, they deliver code. So they actually code what they design, and they deliver small prototypes. They deliver small prototypes that can be demoed to the team, that can serve afterwards as templates. They can be reused as templates, and these prototypes can serve also as living documentation. So this is a key practice of Agile Manifesto that can be used by the architects. Now, be safe to fail. In extreme programming, certainly the most important principle of extreme programming is testing, and in particular, test first. Okay, test-driven development, behavior-driven development, you name it. But we start with writing a test. So Ionut told us that the first activity of an architect would be to talk to the stakeholders and elicit the criteria, the entities that are really important for our system. I would say that then the second thing that an architect should do is to write a test for each of these entities. So these tests can range from a unit test to sometimes a live monitoring of the entire system, depending on the entities that we are trying to prove. And then once you have these tests written, then these tests can drive incrementally your design. And afterwards, this test will serve as a demo. And afterwards, this test will serve to ensure that your system is still respecting these entities with time, which is key for evolvability of the system. In the book that we presented, the book from Neil Ford, these tests are called fitness functions. Okay, so the goal of these fitness functions is to ensure that the system that you are building respects a given architectural characteristic. Let's take an example. Concretely, you have elicited as an architectural characteristic, you have elicited that performance is a key characteristic. In this case, second thing that you do is to design a live monitoring of your system, and then afterwards you can implement your design. There are also two other strategies that are helpful to deploy a new architecture by being safe to fail. These two strategies are feature toggles and green-blue deployments. So feature toggles is about coding the feature and deploying it, but the feature would be activated only with a toggle. This allows you to deploy the feature only on some use cases that you can test, get feedback on before deploying to other. Green-blue deployments is also a safe-to-fail strategy. You want to upgrade a subsystem to a new version. In this case, what you do is that you select a given number of instances of this subsystem, and you upgrade them, and you upgrade the others one after the other. So you don't deploy the new version of the subsystems on all the instances at the same time. You perform this progressive deployment. Continuous deployment. This one is also at the heart of extreme programming, and an architect should also apply this continuous deployment practice. It consists in what? In automating the fitness function that we have just seen. So you automate the execution of the fitness functions and you include them into your pipelines. Here we are talking about continuous deployment and not continuous integration, because some of your fitness functions will clearly be relevant only in the deployment context. Let's say, for example, that one of the architectural characteristics that you want to implement and to protect is upgradability. The ability to upgrade the subsystem with a hot upgrade, for example. Okay, to test this, you will need a real environment, and you will need to test this with an end-to-end test. No other possibility. So basically, the comprehensive continuous deployment pipeline of an architect will contain some fitness functions coded as unit tests, some others coded as integration tests, then the provisioning of a real environment, the deployment of a system, and an end-to-end test. Another practice that comes from my lean experience is to take one bite at a time. If you have a big system to architecture, I would recommend you to start by splitting it into several subsystems, define very clearly the interactions between these different subsystems, the APIs, and then start one bite at a time. It's a basic principle of lean software development, where you try to go as small as possible, and you don't start with a big problem. You try to split it. Astronaut architect. Okay, I stole these words from Joel Spolsky. I quote him. He says, "When you go too far abstraction-wise, you run out of oxygen, and you create these absurd, all-encompassing, high-level pictures of the universe that are good and sexy, but they don't actually mean nothing on Earth." And so these people, astronaut architects, they cannot even code a line of code. Clearly, in an agile environment, this is clearly not what we want. What we want, as a contrary, is an architect that would be close to the team, part of the team. Let's look at what the architect in the team can do. He can own the design, prototype it, and issue blueprints, references, be the guide, okay? And then he would let the design emerge from the team and regularly review this design to keep the consistency. So basically, you have the architect on board who is regularly doing this continuous loop of guiding, reviewing, adjusting, guiding, reviewing, adjusting. And this way, we have an emerging design that is still in line with the consistency, but instead of having this astronaut architect drawing diagrams, we have a team of architects, because we have given the team the autonomy to make a design emerge from their ideas. So we align them, we give them autonomy, and we review continuously the emerging design. So transform your team into a team of architects. I guess these are all the tips that I would give as an agile coach to an architect. So I think that with what Ionut said and what I just said, I think we can just let you go now. It's easy, right, Ionut?
Not quite, Xavier, because remember we had some challenges when we put all of this in practice. Let's see what we faced actually in practice, because the idea with the architecture, the architecture mainly it refers to the internal quality of the product. It's not very visible, or it's not very straightforward for the product owner, this internal quality. And the role of the architect is to make it valuable and make it to be prioritized in the backlog itself. And this is where we struggle. For example, the ideal backlog is the backlog that should contain tasks in terms of new ideas. For example, I want to try something, I want to put something, I see something which I might see as a better benefit for a particular module of the product. Should I try it on my side? For example, if I see something that could prove as being more efficient, a third-party API or a replacement of something. Also, there might be tasks regarding to the technical depth or some sort of evaluation feedback also coming from the architecture standpoint, because as we do for the code review, we can review in the same way the architecture. Also, there might be tasks related to those ASRs, to those ELTs. For example, if the customer wants to implement the horizontal scalability, those are tasks regarding to this horizontal scalability belonging to the ASR. And also there might be tasks related to few constraints or lifecycle requirements. For example, I need to interact with an external system. I need to develop the logic in order to be able to communicate to that one by knowing the external API, by being able to create and send the proper requests and all the things around. And also it should contain functionality. So this would be the ideal backlog. What we ended up, because it's not so easy to align with the product owner, at this stage we created some sort of mutual agreement that our product is a mixture between functionalities and architecture plus other technical things in different proportions. For example, functionality is 70% and architecture and other technical is 30. You might say that yes, but it's still a rule. Yes, it's still a rule. We know that it's not the best way. At least this is a current workaround. We add it in our environment to coexist with the functional guys. We might find better improvements in the future, but currently it fits our need and it ensures the product shapes both functionalities, satisfy the product owner, but also it ensures evolvability. We deliver a good internal quality because all the architectural and technical stuff are supposed to do that. So all of this being said, I would like to thank you all for your attendance. If you want to get in touch with us, you can chat with us on Twitter or directly on the LinkedIn. Thank you so much for your time.
Thank you.
And if you might have questions, we will be happy to answer them.
Guys, can you see a question from program language choose?
Yes, so there is a Valentine who is asking, can we combine different program languages in one project? Ionut, what's your take on this?
Yeah, actually, there are different approaches. I read a nice article written by an architect that he favors combining multiple languages in a project where they use microservices. How is that? For example, each microservice was built in with an appropriate technology stack that is different from another's. This is very good because it's the same idea with polyglot databases. You can benefit of the strengthness of those programming language. For example, why I should Java if I'm very, very keen on performance, why I shouldn't be more native, for example, C++ or Go or something else. So the answer is definitely you can combine. On the other side, you should understand the consequences, because you add complexity and it's more difficult to manage your program in time. By the way, if you are looking towards big companies like Google, like Amazon, like LinkedIn, they really do that. They really use few programming languages decided by at an enterprise architecture level and very, very suitable on that particular case. However, you can use that, so I don't encourage you to create a zoo of languages. So this is my idea.
Yes, if I can add something, I second Ionut, and I would say that everything comes with a cost. So you will pay also here what you will lose by doing this also is the fact that if some teams don't know this language, they wouldn't be able to contribute to this service. I mean, in a source mode. But yes, having the language that fits exactly the service that you're supposed to do is a good thing.
Okay, and the next one was tell me a little more about serverless architecture. So basically, it wasn't like a target for this presentation. It was just an idea. The thing with serverless architecture is like I develop something and I deploy that component to a different infrastructure provided, for example, by Amazon, by IBM, and all these things. In this way, the idea with this, I create my component, I deploy it, so it's their infrastructure, it runs in their infrastructure. For me, I pay per usage, I pay when I have requests, it's easier for me. However, I marry in one way to that vendor, because if I create all the things in Amazon infrastructure, for example, if tomorrow I decide to go to IBM, it's not very, very easy to do that. I would say it's like the same idea with the frameworks, if you use frameworks in your core business logic. There is a very good presentation on serverless architecture. I don't know the author by heart, but I can post it on the forum, and I recommend you to that. However, it's not our key point, this serverless architecture for this trend. But I think the basics we gave you. Okay.
I can next answer Maxime, who asked, do you consider architectural only at the prepare stage, or is it possible to put architectural practice for the system is already on fly? Well, architecture is not only at the prepare stage, it's ongoing task, of course, because the system is also evolving, as we said. So usually what I've seen my architects here, what they do is like, yes, they define the basic design, they define the guiding principles, and then they review and they check that the emerging design is in line with these principles. But they do this also, they check the design for the system that is living, so who is moving, who is upgrading, and so it's really an ongoing check. And by the way, as we also apply the just enough architecture, it's clear that it's just enough now, and then 2 months later we need something else, and so it's really a living thing and a living activity.
Okay, so I'll take the last one, which actually linked to serverless. So basically serverless is just a way to get rid of DevOps in a specific way. Yes, you pay less effort for DevOps. You actually don't too much care because it's not your infrastructure. Actually, yeah. You still need to develop your product with all the elites. Yes, of course, they are the most important ones. Pay very careful. It simplifies the DevOps, the infrastructure part, but the other stuff like elites, they still remain valid. And I'll take the next one from Artem. He said there was a slide with runtime characteristic and other characteristics like maintainability, loose coupling. And I heard that you suggested something like postpone those performance characteristics and address them later. Have I understood them correct? I was said a slightly different. I would say that first focus on design principles and don't sacrifice those for performance. For example, don't sacrifice loose coupling for performance or composition over inheritance, because these are the first principles. However, if in your product the performance is primordial and you, for example, you want to design a trading system on real to be very, very fast in terms of throughput, in terms of response, of course you should complement those with performance and you should keep that in mind from the first very beginning. Why? Because performance adds you mix those design principles with some specific tactics. So if you don't pay careful attention from the beginning, it's later on, it might not be so easy. So be careful. I think it was clear now. First, pay careful on design principle, but also don't lose the focus on your abilities which are fundamental for the business.
Okay, I think I can take the question from Nick. What are your recommendations for presenting architecture work to stakeholders during system or iteration demo that's limited to 3-5 minutes? So actually, what we do in these demos is that we present working software. So as I said, the architects, they don't demo a documentation or whatever. They code a sample, they code a prototype, okay? And so they arrive at the system or at the iteration demo, they say, okay, this is the ability that we were asked to work on, and here is a small program that proves this scalability or this upgradability or whatever. Let's run it. It runs, and bam, and it takes 5 minutes. So they don't demo all the principles, all the work behind. They just demo the result, which is the working software, the working prototype that proves this ability.
The last one is about recording. Yes, definitely the recording will be available, sure. It will be on LTS website, actually.
Yes, the recording will be on LTS website, and you can find the recording on our corporate YouTube channel. It's Luxsoft Corporate, so you'll be able to find the recording of the webinar, I guess, in a week. So again, thank you so much. It was really interesting, and we'll see you next time in next webinars.
Thank you so much. Bye-bye.
Bye-bye.
Bye.
Bye.